Hi, folks. Thanks for joining today. My name is John. I'm one of the co-founders at Arthur and lead sort of the machine learning side of things. And happy to have you join for this discussion we'll have on um, the use of generative AI. And so that means LLMs, that means LMMs, that means other sorts of foundation models that you might be using right now in the media. So that's going to be editorial content. We'll discuss a little bit about sort of the legal landscape and some discussion around some of the unique sort of needs that that folks in the media sort of have for these new technologies. I can't see chat, but I will check it occasionally. I'd love for this to be a here, a little blurb here saying that I can be your chat bot for the next 30 to 40 minutes. I'd love for this to be an active Q&A, but if you're not comfortable doing that, feel free to, just type some texts into chat and we'll read them at the very end of the discussion. Also, feel free to reach out to me or to others that are here. So again, a quick summary of what we'll go over. Oh, I see something in chat already. Look at that. Oh, please use Q&A. Okay, great. I will try my best to watch the Q&A. So a quick summary of what we'll go over today. So I'll give a brief overview of sort of the makings of a present day, and I'll couch this in large language models, but you can think of it as like a generative AI application or a large multimodal model application as well. The makings of a present day LLM. And so this is going to come through what we're seeing at Arthur as we deal with enterprises and SMBs, and also sort of what I'm seeing on the academic side of things. So a little bit on sort of the cutting edge of what's out there yet, might not be in production quite yet. I'll flip into a discussion of some things that we're seeing on the media side as well with Arthur. So one of these is the use of long context windows, which are a necessity, I would say, in media and the legal landscape, as well as in medicine. And I'll discuss what that is if you don't know what that is. Watermarking. And so this is an interesting space. It's not new. It's about 1,000 years old or so, actually. But it's certainly of relevance to the media, which is going to be, in tracking, for example, fake or real, quote unquote, news when it comes from, different sources, or being able to detect or try to detect, generated content versus human created content. That could be text, that could be images, that could be video, et cetera. Obviously, it's going to be an interesting year with the election in the US as well as in many of the democracies in the world right now in this space. And so this is an interesting focus area. I'll do a little bit of an explanation there. And then I'll end with a discussion of a couple of the big lawsuits that are happening right now. And, I'm obviously not a lawyer, so take what I say with a grain of salt, but there are some very, very large sort of legal workings going through the process right now. I would expect this to be a very sort of interesting year when it comes to deciding what you can train on, and if generated content is violating the copyright, that kind of thing. So cool. Again, use the Q&A if you have any questions, and without further ado, I'll take it from there. So we are a for-profit company. This is my one sales sort of slide. This is Arthur's view of a modern sort of modal large language model or Gen AI-based application. We roughly, as a company, split this into 3 different areas. And so I'll give you a different company's view of LLM applications or Gen AI applications on the next slide, but just to sort of give us some credence here. But if you're interested in seeing how Arthur views this, we roughly split it into 3 verticals. One is going to be at the application layer. So that's going to be you, a user, basically, right? So somebody who's coming in and going to chat.openai.com or whatever, or using, your internal chat bot at whatever company you're at. This is going to involve things like prompting. So that's you interacting with the system, or that's somebody who is designing the system interacting with the system prior to you using it. So that would be maybe incorporating a system prompt into the mix, which is going to say, hey, as an LLM, don't do X, maybe do Y. You should try and scoot toward, Z value for a particular firm, et cetera. That's also going to be dealing with what are increasingly popular. I don't think we've seen any in real production in enterprises yet, but I think it'll happen this year. Things like agents that are calling out to additional information, and so on. And that's also obviously the output of the system itself, right? So you as a user are going to see output from a system. That could be text that's generated from Claude or from Bard or whatever. That could be text and images, that could be video and so on. The inferencing layer right? So inferencing is I have a trained model and I want to put some inputs into the model and then I see some outputs come out. That's going to be in the context of generative AI. It's going to be, let's talk about text. Text is flowing through some application, and you're asking for the next token, the next token, the next token, and so on. There's a lot obviously to do here. One of these is going to be making sure that things are behaving well, right? And so we have a product called Arthur's Shield that sits between this application layer and the inferencing layer. You may have heard these in the news called firewalls or guardrails and so on. And this is basically saying, hey, we want to make sure the user isn't doing bad things. And we want to make sure that the application itself isn't passing back bad things to the user. What do I mean by bad things? That could be toxicity for whatever definition of toxicity you have. That could be something like a biased response. That could be something like, you'll hear them called hallucinations or just incorrect information in chat. Or that could be, more nefarious things like a user trying to jailbreak a system, right? If you've seen any of these sort of discussions of like making car dealerships chatbot start selling a rival's car, that kind of thing, trying to prevent that sort of interaction. Cool. I don't know how to answer this question. My vocal fry is a challenge. Thanks, anonymous person. You're welcome to, I don't know, turn the volume up. Cool. So on the development layer, this is the third of the three verticals. We have selecting LLMs. This is actually a very hot area when it comes to dealing with large language models. This is saying, hey, we have a bunch of different models that are out there. Some of them are expensive. Some of them take a long time, but they perform really well versus some of these might be built in-house and are a little bit less expensive to use and are sort of a lot faster to use as well. And so how do I select these and so on? And so we have a product called Arthur Bench, which sits sort of in the evaluation space, which would help you select some of those large language models. And then finally, throughout this entire process, this is machine learning, it's automation. One wants to watch over everything that's going on. And so we have another product that sits in the monitoring space, and that's going to say, hey, you might have some sort of distribution drift in the way that your users are using a system. I want to alert you to how that distribution drift is impacting your downstream KPIs. Cool. So that's roughly how we see a large language, like a Gen AI-based model is what I would say in practice. But you don't have to take my word for it, right? You could take somebody else's word for it. So here is an example of a vector database company. They're called Pinecone. Just sort of every one of these Gen AI companies has sort of a view on how LLM applications look these days. And so I just sort of picked this one out of the pile because I also agree with it, but it's also validation as to the way that we see these large language models. So Pinecone views LLM-based applications with roughly the same eyes that we do. So you're seeing a couple of things here. There's obviously prompt engineering that goes into things. There are these protective guardrails or these firewalls around the way content is generated. But they also have a bit more of an agency pitch to them. And so that's going to be, looking at things like going out onto the external internet, executing code to do some sort of like generative AI-based code analysis, right? So for example, you might pass in an Excel spreadsheet or a CSV or some sort of structured data and ask a question like, hey, what's the average of the fourth column, right? Like, oh, hey, we have some yearly income. What's the second lowest yearly income that we've had in the last 25 years? That sort of thing. So this is something that we're also seeing in practice quite a bit. But again, the use of, for example, being able to go out onto the internet and execute arbitrary code. For example, let's say that you want to do something like look at all of the New York Times articles in the last, I don't know, year and ask questions like, what is the average sentiment of an article in the New York Times referring to China or referring to Ukraine or referring to the United States, something like that, right? So this might be some combination of A, going out into the some combination of private data and public data, and then B, translating some sort of request like what is the average sentiment into some combination of code and some sort of like hitting some that external database to get that information to begin with, right? Like all of the New York Times articles having to do with Ukraine, something like that. There's a lot to worry about when you do that, right? One is the veracity of the response that you'll get back, right? So what if I translate into the incorrect type of code, or what if I grab the incorrect type of articles from my private and public data stores? Hey, I'm going out to the internet, and anyone can put anything on the internet. And so what if somebody puts some sort of adversarially crafted information online to try to maybe misguide me by reporting something that's going to be maybe much higher negative sentiment or much lower negative sentiment for this particular request, and so on. And so there's this real need for active monitoring and for active mitigation when it comes to the use of these newer tools that we're going to start seeing going into production in 2024 in Gen AI. Cool. So, as I mentioned, I'd love for this to be an active Q&A. So if anybody's seen other things that they didn't see on either the previous slide, which is sort of Arthur's view of things, or this slide, which is, just a, I respect the people at Pinecone, but it's sort of a randomly chosen image of what Gen AI-based applications look like. Cool. And so in maybe the next 5 minutes or so, as we sort of wrap up what these applications look like, I just want to make sure that we're all on the same page when we go into discussions around, for example, watermarking or long context windows, both of which are very, very important to editorial content in the media. I want to make sure that we're all on the same page when it comes to another sort of what I would call the 99.9% case of sort of the LLM-based applications that we're seeing in practice these days, right? And that's going to be something called RAG. And many of you probably heard of this, but if you haven't heard of this before, so when it comes to large language models, if you know GPT, right? GPT stands for Generative Pre-trained Transformer. The pre-trained there is referring to the fact that this model was trained on data and then is now in production, right? So somebody else did a lot of work looking at a lot of information and training a model on whatever, the internet, right? There's a lot of good with that, right? You don't have to go out and train these models necessarily, but there are some sort of tricky bits here. So one is that this is a fixed model generally, right? And so it's going to take as input some prompt that's you interacting with the system combined with, for example, some sort of system prompt behind the scenes. And then over and over again, it's going to provide sort of a sequence of tokens, right? So it's going to say, hey, you passed in this sequence of tokens. I'm going to respond in a particular way, right? So it's fixed. The prompt itself, right, your ability to interact with the system is going to be limited in size, and the response is also going to be limited in size. Okay? And there are a couple of, I'd say, are more research-friendly approaches out there that relax this constraint a bit. But in general, when you interact with these systems, there is a fixed limit on the sort of interaction length that you can have with the model itself. And in general, for the model itself, not the system around it, but the model itself, there's no additional learning over time. It's a fixed model. So that's fine in general, right? If I were to ask a modern large language model that has been trained, let's say, in the last couple of years, hey, what's the biggest news event of 1989? We can all argue about what that might be, but one obvious answer would be the fall of the Berlin Wall, right? And so this is the response that ChatGPT gave, which says, hey, the biggest news event in 1989 was the fall of the Berlin Wall on November 9th. Great. So we have a couple of questions around this. One is is that right? Well, there's a value judgment there, right? I might view that as not the most important event. Is that right? Did this event actually occur in 1989? And, I would obviously claim that it did. So in that sense, this is right. But, there are some other issues that might arise here, right? One is, is this information in the training corpus at all for the model, right? And because this happened in 1989, obviously widely reported on, it probably was put into ChatGPT. And so ChatGPT was able to, is the 3.5 or 4, whatever it's using right now, it was able to correctly answer this. But what if I wanted to access, I don't know, more recent data or private data, right? What if I wanted to ask ChatGPT, hey, what was the biggest news event of yesterday, right? I think today is the 23rd, so I want to ask, what happened yesterday? And a couple of responses here. So one is if I ask the model itself, it'll do something, right? So it will either, maybe it's been trained with a particular guardrail in place. It'll say something like, hey, that's after my training cutoff. Or it will hallucinate a response, which would be, it'll just make something up basically, right? So it'll draw the next, highest probable tokens for some January 22nd of 1989 or something like that. It'll find something in some probability distribution somewhere and repeat a response. Or more recently, and we'll hop into this a little bit, it'll use some sort of agent to go out to the internet. In the case of ChatGPT, obviously there's a strong connection with Microsoft Bing. So, depending on the version that you're using, it'll actually go out and ask Bing, hey, I want some search results, I'll get some information and so on. And that's getting more in line with what we'll talk about now, which is the ability to access additional information that was not included in the training corpus of the particular model, right? So going out to the internet and asking for questions, or going to a private data store and asking for questions as well. Cool. Now, I do want to say, like, if you have additional data, you can go and fine tune the model, right? So you can go and you can take your model that you grabbed from OpenAI or that you grabbed from Hugging Face or whatever, and you can put in additional sort of training pairs, right? You can have some inputs and some outputs and so on, or you can just have some inputs and you can train additionally to sort of incorporate that knowledge into the model. And fine tuning is extremely common, right? And one of the reasons why is because you can incorporate obviously new information into the model, and another is because you can use this to well, a couple of things. You can use this to play around with context window lengths, but you can also use this to kind of scoot the model in a particular direction. So if you're doing like value alignment or something like that, you might want to do this as well. But there are some negatives to this, right? So one is, it's time consuming, right? You have to come up with new information to pass into this model. It takes time, obviously, to train a model. It takes time to fine tune it. Same sort of mechanics there, right? It's going to take money. It's going to take power. It's going to take GPUs, et cetera, et cetera, et cetera. And then, what happens tomorrow, right? Like, and I ask, what was the biggest news event of January 23rd? And then what happens the day after that? I ask, what's the biggest news event of January 24th, right? Like, I have to keep doing this over and over again. And, I'm going to keep incurring that cost. I'm going to keep incurring that time hit. I'm going to keep incurring all the effort that went into, crafting input-output pairs and so on. And so this should just be one of your sort of one of the tools that you have in your toolkit. It shouldn't be the only one. An interesting sort of side effect of this is that, hey, what if I can lean on what we've been doing anyway in computer science for decades, right? What if I can lean on information retrieval to sort of augment my system? Okay. So I'm going to combine some retrieval augmented generation, or like RAG, which is what I'm talking about here. I'm going to combine some techniques from information retrieval with pre-trained models. Okay, so my first step is I'm going to go out and query some database of documents. These could be public documents, these could be private documents, but the key here is that you can think of this as effectively like a traditional database. There are some sort of fancy tweaks that you put around this. We can talk a little bit about vector databases in this talk, but you can think of this effectively as a traditional database. So you have a bunch of documents, you store them in some way, you have role-based access control around it, you have all these atomic transactions, you're able to track who's doing what and what happened and so on. You're going to query a database for documents, and then you're going to use that query, which is going to return some relevant documents. You're going to combine that with the prompting that the user is doing, and maybe some other sorts of system prompts and so on, to generate a final response. And if you're not following that, I'd like to just walk through a quick visual on this to sort of show what this looks like. So we're going to have some sort of prompt, right? So this will be a system prompt along with a query. Let's say that you are wanting to ask that New York Times question. You're wanting to ask, hey, in the last, month, what's the average sentiment of a New York Times article on Ukraine? I will prompt that. That'll go into my let's say internal chatbot at the New York Times, and before answering you, I'm going to look at your question and I'm going to embed that in some way, and then pass that embedding into a vector database or some form of database, right? So at a very, very high level, the math doesn't matter here. I'm going to pass your query into a database, and I'm going to get back relevant results about that query. So in this case, I might have put all of the New York Times articles from January of 2024 into a database. Maybe I chunked them up. I did some other sort of fancy stuff to make them easily searchable. And then I pass in this Ukraine sentiment query to that database, and I get returned a bunch of Ukraine documents, right? So I don't get any Trump documents. I don't get any China documents. I don't get any, DeSantis documents. I only get back Ukraine documents. I then include those alongside my query into a query to an LLM. So this could be like a GPT-4 or a BARD or whatever. Okay, so I'm going to have what is the average sentiments of a New York Times document in January 2024 as text. And then I'm going to have basically snippets of relevant text from the New York Times about, in this case, Ukraine, right? And in January 2024. And I'm going to pass all of that into my large language model, and then I'm going to get back a response. And that response is going to hopefully be an analysis of the sentiment of that text that was passed in. So in this way, I've not change the LLM itself, right? You see LLM here, that's going to be whatever, GPT-4 or whatever. But I am able to incorporate into this system new information by going out and hitting a private database, in this case, all of the New York Times articles from January 2024, and then passing that into the fixed model itself, okay? So this is in many ways much cheaper than, for example, fine-tuning a model, right? Because I'm able to just add new information to this data store, and then when I hit it with a new query, say tomorrow, I'm going to have new articles in it. I haven't changed the model at all. I've only changed the data store, and then I'm able to pass that into the system and so on. And in that way, you're able to incorporate some sort of new information or private information into a system. So what we're seeing across the board with Arthur is like this is the dominant paradigm for large language model based applications, but also increasingly multimodal applications. Cool. So this is top of mind for basically everyone. Just to quickly go over some of the options that are out there. There's open source options like, for example, Weaviate. There are non-open source options like Pinecone. These are sort of newer startups that are building from the ground up in an AI first way. They're vector databases that are building them from the ground up. There are legacy players that you may be using internally already. For example, Elasticsearch, Postgres, MongoDB, and then obviously you can roll your own, right? So just like with traditional databases, in many cases, if you're just experimenting, like you don't need one of these. You just need to roll your own, like single line of Python or whatever. So at some point you make that transition from a hacky sort of homegrown effort into a fully managed data store. We're going to see how this plays out in the coming years. It's completely unclear to me who's going to win these battles. It might be the incumbents, it might be the new players, and so on. There's this huge overlap between information retrieval, traditional information retrieval, right, which Elasticsearch is extremely good at, and the database aspects of this, obviously, and the vector database aspects of this as well. And so it's going to be interesting to see sort of how this plays out in the coming years. There's a lot of sort of traditional problems here that, if you want to really dive deep into this, you should be looking both at the database literature as well as in like information retrieval writ large. So similarity search, right? When I pass in that query, average sentiment of a New York Times article about Ukraine, I need to be able to somehow find documents that are about Ukraine in the New York Times from my data store and so on, right? Like this, again, is traditional search in some sense, but there are a lot of open problems in that space. And there are a lot of kind of cool, newer, old, but maybe more important problems. Like how do I actually sort of separate my long documents in such a way that I'm able to search for them quickly, but also efficiently like in a high accuracy way in a vector data store. Because, as I mentioned on the last slide, when you find new documents in, say, a vector database, you then end up adding them to the context window. You end up adding them basically to the input to a large language model. And so as you add more and more and more of these documents, you're adding more and more and more tokens to the LLM. And A, you have a maximum number of tokens that you can actually add into this, and B, it's going to cost you money, it's going to cost you time, and so on. So there is a real sort of efficiency trade-off here to be made. Yeah, and then other traditional IR issues here, right? Like you want to get maybe not for that Ukraine example I was using, but maybe I want to get I want to query like what were the top 5 topics that the New York Times covered in January 2024. I want to get a diverse set of articles returned to me when I ask that question, because if I only get all of the, let's say there's one particular event that happened in January 2024 that was really heavily covered. If I only return that one event, I can't even answer the question, what were the top 5 events? I'm only going to get that one event. So there's going to be a diversity requirement in the return as well. Cool. Yeah, and so one additional thing, I mentioned this a little bit earlier, when it comes to incorporating information that's not going to be included in the training data for a particular large language model, one thing that's really sort of taking off, especially in the last, I would say, 6 months or so, is the use of sort of external code execution, agents that will go out and act in a particular way to gather information or take actions on the internet, and other forms of plugins for these large language model-based systems. And these are... Jennifer asks, what are the main challenges in deploying LLM-based applications, considering options like Weaviate, Pinecone, and legacy players? So Weaviate and Pinecone, like I mentioned, are vector database companies, right? So they create and maintain just one part of these large language model based applications. And so when I look at large challenges in deploying sort of LLM-based applications, I mean, the ones to me are is data curation, right? Like there are a lot of sort of traditional issues when it comes to deploying these automated systems. Taking a step back, so when people talk about LLM-based applications, right? Like the model itself, the large language model itself, is just one part of a very sort of complicated system, right? Like you can see this little image here in the top right, which again is coming from Pinecone, talking about the use of a model in a larger system. So what I would say is the biggest challenge to deploying these LLM-based applications is sort of understanding what you want to get out of them, understanding the costs for using them, understanding the ways that they might fail. They're not even really about the specific model itself, right? They're not really about, are you using GPT 3.5, are you using BARD, are you using some, model, open source model like a Llama or something like that. They're really more about traditional sort of software engineering and system design questions like, how do I know when this thing is working? How do I know if I'm deriving value from it? How am I making sure that it's continuing to work once I put it into production and so on? And so to me, those are the biggest questions. I'd be happy to ask to answer a more specific question about a particular component of that system as well, if you'd like. But to me, these aren't, when you look at like a chat GPT or something like that, right? Like the model is really, really cool. The thing that is responding to you is really, really cool, obviously, but these are highly complex software systems that involve all of the complexity of large software systems. And so many of the problems that come from deploying these things aren't particularly new. It's just about understanding sort of what you want to get out of the thing and understanding when it's working and when it isn't working and when you're deriving value from it. Cool. So I won't spend too much time on agents here, but many of you who are using these systems are running into these days, which is really, really cool. But roughly speaking, it's a way to launch some code that goes out and does a thing, right? It's going to sense potentially the context that it's operating in, and then go out and try to do something for you. And yeah, I think 2024, we're going to start seeing a lot of these being put into deployment. And I think monitoring these is going to be very, very interesting. And again, like I just mentioned, deriving value from them, understanding when you derive value from them is going to be very interesting as well. We're going to keep seeing these incorporated into RAG-based applications. I don't think this RAG paradigm is going to go anywhere. It's such such an obvious way to incorporate data into a system where you're not wanting to constantly, retrain a model over and over again. But there's no reason why you can't have these RAG-based systems also working in lockstep with agent-based systems as well. So I think we're going to see a lot of that in the coming year. Cool. So one thing that we've seen really, really matter in editorial content in media applications when talking to folks who, do deep research and then write sort of long form articles about them, or just do deep research and then write short articles about what they've been reading about, is they're really hampered by the context window in a lot of these models, right? So early 2024, which is when I'm talking, right? So it's January 2024. Context windows for models are really running the gamut, right? So many open source models are still really, really small, is what I would call, right? Small by modern standards. So you're talking 2,000, you're talking 4,000 total tokens, right? And as a reminder, roughly speaking, if I'm speaking to you in English right now, in English, roughly speaking, using most tokenization techniques, a token is roughly, let's say, 75% of a word. That can change a lot, obviously, if we're talking about programming-based applications or if we're talking about different languages, right? We won't go into this in this talk, but if you look at like Chinese tokenizers versus like English tokenizers, very, very different behavior there. But roughly speaking, let's say 2,000 to 4,000 tokens is, let's say, like 3,000 words, something like that. Okay, so it's long, but it's not like that long, especially once you start incorporating the system prompts, and especially once you start incorporating these RAG-based returns, right? So if I have some sort of, let's go back to my what's the New York Times sentiment on the Ukraine question. If I ask that question to a RAG-based system, I'm going to get 10, 20, 40, 50, 100 articles, snippets from articles back from the New York Times. And that's quickly going to exhaust my budget of, let's say, 3,000 words, so 2,000 to 4,000 tokens. GPT-4, I think right now is a 32,000 token limit. So that's getting quite a bit longer. And there are some much longer ones out there as well. So Anthropic's model, I think, has 100,000 limit, still the one that's in prod. Mosaic released I guess maybe 8 months ago now, a 65K model. At that range, you're thinking about, like, if I'm not doing a RAG-based application, I can pass in effectively an entire book, right? So that's pretty cool. But again, if I'm asking for private information to come back into my system, I'm quickly going to exhaust that budget, right? So you have to remember that that budget, that context window, is a combination of the system prompt. So you might not even have access to this in particular applications, but it's basically, various sort of examples. You might be doing some various ways of moving a model in a particular direction, along with your interaction, specifically your interaction with the model, along with whatever's getting returned from that RAG-based, that retrieval, along with whatever might be getting returned from whatever agent's going out and hitting the internet, along with the response from the model itself. All of that has to fit into this context window. And so especially in the media, especially in the legal world, we all know lawyers like to write a lot, and especially in the medical world where you have long medical documents, even these long context windows are a big issue that we're seeing. The space is progressing really quickly, really quickly, right? So we've gone from like sub 1,000 context windows a few years back into 2,000 to 4,000 being table stakes for open source, into 100,000, which was absolutely like unbelievable when that came out. I have no doubt that in the coming years we're going to see this increase. That's going to be in a couple ways, right? So one of those is going to be through like just raw engineering tricks. One of that's going to be through R&D improvements, like the use of like alibi and flash attention and so on, to do better training of traditional transformer style models, better training and better inferencing. Some of that might be through the development of new architectures, right? Like state-based models are pretty cool. And then some of that might be those probably are the two directions there, right? So hardware advances are another one, right? Like these things just require a ton of memory to store, and they require a ton of basically GPUs to train and do inferencing on. So all those three are going to, I think, develop very, very rapidly in the coming year, just because there's so many people focusing on this and there's so much money flowing into it. But I don't see this issue going away necessarily. And so again, if you're sitting there as somebody who is, say, a journalist, how do you handle this? Well, one is going to be really focusing on the way that you're doing that retrieval. So really, really tamping down on maybe the length of the responses that are coming back to you based on that RAG step, or doing multiple steps, right? So like doing multiple calls, doing some sort of summarization of what comes back, asking additional questions, doing additional summarization, and so on. And then kind of is unsurprising to say, I mean, if you just have more money and more hardware, then you can do a better job here. But give it 12 months, and a lot of these problems, I think, will they'll still exist, but they'll be a little bit less of a pain. Cool. So just moving along on things that might impact sort of the media world. So the Biden administration put out an executive order on AI in late 2023, which was one of the biggest, I would say, like paternalistic steps that a government has taken worldwide when it comes to setting sort of the tone for AI regulation and AI development in a particular country. And so I'm just going to pull out maybe three parts of that that I find particularly relevant to the media. So one is sort of on the FTC side of things, right? So it's going to be on encouraging, promoting fair, open, and competitive AI ecosystems. This is very, very interesting in the sense that, like, we have these large players in the US and abroad, obviously. So we have OpenAI here in the US, we have Google, we have Microsoft internally developing, our neighbors to the north, Cohere, we have Anthropic, and then we have obviously international competitors here as well. There's this evergreen topic of how should we promote competition amongst companies? And I think it'll be interesting to see that play out in the coming years when it comes to AI, because it does just cost a lot of money to train these models. You need to be able to have a lot of data. You need to be able to train these enormous models. You need to be able to run the systems that allow 1 million, 2 million, 10 million users to use these systems, which are very expensive and so on, which is very valuable, but also as a country, it seems like the Biden administration also wants to promote startups and upstarts and academia and so on in the space as well. So how will that play out in a way that affects the media? Well, one is it's an interesting thing for the media to cover, right? And so not making value judgments on any sort of, monopolistic breakups or things like that. But I think it'll be very interesting to see this play out in the coming years. Two is I think, when it comes to differentiating, well, I'll come back to this a little bit, but like when it comes to large models, we'll talk about this a little bit toward the end of the talk, but like when it comes to, for example, well, let's say the New York Times, right, selling information to models, selling information for those models either to be trained on or to have access to. It'll be interesting to see, how either having a smaller landscape of folks who are buying that information or a larger landscape of many, many smaller models who are buying that information plays out in that regard as well, right? So in the media, you're in a very sort of special place in that you're doing, deep content creation that people also find very, very valuable. And so, I would expect in the coming year or 2 years for some of those licensing deals to really sort of be hashed out. These have obviously been announced. I think OpenAI has announced at least one and maybe two so far. But yeah, it'll be interesting to see how that plays out if there are only a couple large players versus a lot of large players or medium players. Two is on content detection. Okay, so here's a direct quote, I think, from the EO, which is saying, hey, we want to look at authenticating content. We want to track its provenance. We want to label synthetic content through the use of things like watermarking. We want to be able to detect synthetic content, right? So these are all awesome things, right? The ability to do this, I think, is extremely valuable. It'd be the ability to say, hey, this particular model created this particular image, or I don't think this image was created by automation. I think it was created by a human, or this human created this image and I have this stamp that's associated with it. That's all very, very valuable. And I mean, obviously is going to have a huge impact on sort of editorial content that's out there. It's also really, really hard. Like, to my knowledge, and I feel pretty confident saying this, there are no, I won't even say foolproof, there are no good enough methods for doing this in text or in imagery right now. And there's a lot of work that's going into understanding better ways to do watermarking, but it's just not there yet. And, there could always be the case that a company has done this behind the scenes and just hasn't, shared how they do it. But I don't believe that. And so it's interesting to see the EO calling this out specifically when we just don't know how to do it yet. So what is watermarking? The TLDR here is that I'd like to identify some content from a particular creator, and I want to make that identifier hopefully not perceptible necessarily, right? So I want to have the ability to give you my beautiful artwork that I created, give you my beautiful creative, give you my text that I created, and have the ability to tell you, hey, yeah, I did this, but maybe not have it be, my signature on it or something like that, right? So the ideal here would be some sort of robust, ideally invisible signature that's attached onto creative content, text, images, etc., that ties that content back to a particular creator. That could be me plus an AI, that could be an AI, and so on. It's often used, this isn't a new concept necessarily, right? So like it's often used for example, detecting pirating. Like there are very basic watermarks. If you've been on a plane recently, right, you're going to see United Airlines like occasionally flows across the video that you're watching. That's a form of watermark. It's obviously very easy to remove. And it's going to help with pirating. That's going to help with unauthorized distribution of those videos. 2024 will be very interesting in the US and many other democracies. It's going to be, we're going to see people at least attempting to use watermarking to brand video content, imagery, and text about elections, right? And I don't believe that we have the ability to do that yet. So we're going to see, well, here's a prediction, is that we're going to see some pretty high-profile failure cases here as well. Really kind of interesting long history. I got a little bit nerd sniped when making this slide, and yeah, the first watermarks almost 1,000 years old. I think in the 1200s or so. You would attach stamps to paper makers, paper that they were making that would basically associate paper that was made with a particular producer. And so that's sort of where the water part of this coming from, and they were very, very hand-coded. That continued for a long time, for centuries. Industrial papermaking came around, and the bespoke paper career was not the one it used to be, and so watermarks changed at that time. But the digital revolution came after that, and watermarking became very, very popular again. And so there's a lot of work out there on embedding information into audio, images, video, text, and so on. It's often, in fact, I would say typically hand-coded, or at least has a human in the loop. And so we ideally would not want that anymore in this sort of Gen AI age, because it's so trivial and so democratized to be able to create extremely high quality imagery and text that basically a human can't tell is made or is not made by another human. So for folks who use DALL-E, which is OpenAI's text-to-image model, it's now incorporated into the ChatGPT user experience, but back in the day it was a separate product. The watermarks on DALL-E images used to look basically like this, right? So without the OpenAI logo, there were just 5 little boxes at the bottom right of an image. So this was included to trigger the realization in people who see these images that it was made by OpenAI. I mean, you can obviously just crop it off. So now that DALL-E's incorporated into ChatGPT, I was sort of playing around with ChatGPT last night when making these slides, and I asked, hey, are your images watermarked, right? So OpenAI has actually announced that they do watermarking on images and text. Meta does this as well. Google does this as well. So I thought, hey, what's it going to say here? And it said, yeah, our images are watermarked. You can see that in the bottom right corner of the image, which is the image I was just showing you on the last slide. It serves to identify images and so on and so on and so on, right? And so I asked for a couple of images, and over and over again, it made the claim that there was a watermark there in the bottom right. You can see it here. Well, you can see the text here, the claim here. I can't actually see a watermark there. And so either this is wrong, either these images aren't being watermarked, and ChatGPT, for whatever reason, is still thinking that we're doing DALL-E style watermarking, or there's something else going on. Okay, so I asked again, are you sure there's watermark? I apologize. I asked for another one that says, hey, can you please generate that same image with a watermark? And it did the same thing, where it said, hey, there's a DALL-E style watermark included in the bottom right-hand corner, and I just can't see it. So this is moving very, very quickly right now. It's obviously no proof of anything. I just found it kind of curious. Corporations are claiming things right now. So all the major companies, to my knowledge at least, have announcements around watermarking. Some of these are claimed to be in production. Some of these are sort of R&D white papers. And shouting out Meta here, Meta has been an amazing community member in their support of open source everything, basically open source models, open sourcing a lot of the research that they do. They've claimed that they've developed an invisible watermark to track AI image origins. Sure, they have a paper that's associated with this. Just like any other paper in this space, though, you can break these things, and so they're open about that in the paper. It's cool to see them. And just to flash some other sort of interesting articles that folks on this call might find interesting. Google has watermarking for a lot of the generated AI music that they're putting out as well. And again, I have no doubt that this is breakable, but it's interesting to see these getting announced. And again, shout out to Google for open sourcing a lot of their research in this space as well. So in general, blanket statement, it's easier to watermark continuous things than discrete things. So what I mean continuous, I mean like an image or a video or audio, right? Where I can make like a very, very small change in, I don't know, the amplitude of a particular sine wave or something like that. And as a human, you're going to have you're probably not going to notice it, right? It's going to be imperceptible. When it comes to text, though, if I change a single character, right, you're going to probably notice that, right? If I change an A to a B, in most cases, you're going to notice that. And so adding in these imperceptible watermarks to text has traditionally, or something discrete like text, has traditionally been a lot harder than it is to add in a watermark to something like an image. And, just in the interest of time, I won't go into this in great depth, but I wanted to call out one really cool paper that came out over the summer that looks into watermarking large language models. And again, the authors of this paper, to their credit, are extremely open about ways to break the watermark. But to my knowledge, this is, I would say one of the strongest baseline watermarks that's out there that you can read about. And, take a look at this paper. You'll see some of the ways that it's breakable, but also some of the ways that they're kind of doing cute ways to detect generated content. And then, TLDR for this paper is basically, you can look at some distribution of the text from a particular LLM, and you can use that to create, these can be secret or these could be semi-secret, a list of sort of red and green tokens that shouldn't appear from a model or should appear from a model. And then depending on how much information I hold back from you as a user, like let's say I'm OpenAI or something like that, I'm able to compare roughly the distribution or the probability distribution of these green tokens that come out to tokens that came out from, say, a human-generated text. And you might be thinking, hey, can I do things like, as a human, can I swap in different tokens? Can I use a thesaurus style attack? Can I swap in different synonyms for words and so on? And there's a nice discussion in this paper about ways that does work and ways that doesn't work as well. But I think we're going to start seeing, again, additional work in this space coming out. We're not there yet. And so when it comes to editorial content, when it comes to the media, if people are saying, hey, here's a watermark on that image, almost certainly somebody, go online, find a bored 15-year-old, like they're going to be able to remove that watermark, right? Using, techniques that they learn on various forums, techniques that they learn from reading papers and so on. So just know that these things are still fully breakable, at least in the open. We'll see if that is still the case in a year or 2 years. But to the Biden administration's credit, by calling this out directly in that executive order, I think we're going to see a lot of work that goes into it. And I think, if we can have these sorts of watermarks coming out, that'll be obviously very, very good for society. And then the last couple of comments I wanted to make. So one more call out to that executive order that I think is very, very relevant to the media is this comment on promoting responsible innovation, competition, and collaboration with the blah, 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 blah. Standard sort of political speak there, but tackling novel IP questions and other problems for protecting inventors and creators, right? So this is, at Arthur, when we talk to creative designers and to content managers, folks like that, IP is a huge issue right now, right? And I don't have a public opinion on this, but there are these large lawsuits that are coming out right now. The New York Times recently filed a lawsuit against Microsoft very recently, actually, sort of toward the end of December, looking at copyright infringement, basically claiming that New York Times articles were used to train Gen AI models and Gen AI tools, and that this is leading to unauthorized commercial use. So just to go through a couple of these claims. Summary info, right? So one of the most common tasks I would say that people use Gen AI for is to take as input, a document and ask, hey, here's a transcript of a meeting. What is the one paragraph summary of that meeting? That sort of summarization the New York Times is claiming for example, an article is violating a consent rule that they have. And they're claiming a lot of harm here. They're claiming a lot of this comes down to the consent. So the ability to incorporate that information into Microsoft or OpenAI models without, say, the New York Times being compensated for that, or without the New York Times actually agreeing to that. And so this is going to be a very, very interesting legal case to watch in the coming year. There are similar, I won't say identical, obviously, because the legal similar in spirit lawsuits that are currently ongoing with, for example, Getty Images against Stability AI. So those are the folks who made Stable Diffusion, which was sort of one of the first text-to-image models that really sort of took off. And those will be interesting to see play out over the coming year as well. But again, the fact that this was called out by the Biden administration, and the fact that we have these very, very sort of high-profile lawsuits that are happening, sort of in lockstep with this New York Times article, there are also some very large authors that are suing very similar players like the OpenAIs and the Microsofts of the world. Yeah, I won't make a prediction here on what's going to happen, but it's certainly going to be an interesting year in IP, IP protection when it comes to Gen AI. I think I'm at about 50 minutes in. So I will just flip to, I guess, questions now. Yeah. Let me just Anonymous attendees says, how do these challenges align with traditional IR, information retrieval problems, and what new or heightened issues are emerging in this space? Yeah, so a lot of these challenges here, I was just talking about the IP challenges, right? So when it comes to the ability to hit and, oh, no question, by the way, to hit an external data store, how do these challenges align with traditional? Yeah, when it comes to like hitting a traditional data store, right? Like, yeah, just a prediction is we're going to see non-local data stores that you're going to be doing RAG-based access to is my hunch, right? Just because different companies are going to own different information and they're going to have different, information sharing deals that are priced out with different companies that own the LLM side of things. And yeah, I'm not sure how the pricing models will work out there, but certainly we're going to see, the more information you ask of, let's again just talk New York Times, for example, right? Just like if I'm the New York Times and I have a licensing deal with a particular LLM-based company, I might charge based on potentially even the tokens that are returned when you ask me for private information. I might charge based on questions that you ask, right? Which is a very different sort of concept, but I might charge on the tokens that are returned, or I might charge on the length of return of information. And at that point, again, that's just going to triple down on this need for folks to really, really pay attention to the length of the response, right? Which roughly is going to be a proxy for the amount of information that a response gives to you, and well, the cost of doing that, right? And I mean that in terms of time, but I also now mean that in terms of money, right? You're asking for more information from somebody who owns private data. So that I think is going to be a new one in the sense that I think we're going to see sort of a new economic model for the way data works is transferred online, coming out of some of these lawsuits that are coming down the pipeline. And again, I don't know if that's good or bad, but I think it's going to happen. Can I share the watermarking paper? Yeah, of course. Yeah, it's called, I think, a watermark for large language models. It came out in ICML, which is a large machine learning conference over the summer. I think it might have won a best paper award as well there. Yeah. Yeah, Christina did this already. Cool. Any other questions, folks? Oh, I see open questions. Oh my gosh. Hi. So here's one from Mick, an AI safety researcher in laws, evals, monitoring. If foundation model developers incur more costs of compliance, for example, the EU's AI Act's pre-market conformity assessment for compliance with copyright or other pending regulations, how do you see this affecting the ecosystem of agents, databases, and monitoring players? Yeah, so I think the base question there, and Nick, tell me if I'm not getting this correct, but the base question here is basically compliance costs money, right? And this is independent even of Gen AI, right? This is just compliance in general. It costs money. And how is that, if I add additional overhead for compliance when it comes to tech-based applications, what's that going to do? And this is an age-old question, right? When it comes to adding additional sort of hoops to jump through, obviously the hoops are there in the guise of making society better, but you do run into issues, for example, with regulatory capture, right? And so this is something that we're seeing pretty blatantly when it comes to the large players interacting deeply with, in the US, for example, with the Biden administration, but also just across the board, is I can make the barrier to entry very high, and if I am a FANG, right, if I'm a trillion-plus market cap company, then I can pay people to hop over that barrier to entry. But if I'm a startup, I might not, right? And so there are various political tools that one can use. For example, not having startups need to comply until they hit a certain size, where size might be like number of users, or size might be the size of the model, which I have kind of mixed feelings on that one. But we actually saw sizes of the model going into that executive order. I'm not sure how that'll play out, but obviously, if there's a heavy regulatory burden, then the blanket statement there is that'll tamp down on early stage innovation, right? Unless there are ways to encourage that as well. A quick thing that comes to mind, for example, right, when it comes to the use of automation in like lending law in the U.S., the CFPB put together a sort of sandbox that they were public about, where startups could go and operate in that sandbox by sharing what they were doing with the CFPB. And then if they did something bad, right? So if something that they were trying to do ended up doing something very like reprehensible when it came to lending, the CFPB was saying, hey, we're not going to like sue you out of existence. We're going to work with you to make it better. And so I think that kind of hand-holding, this is a new space, right? So like we don't know exactly what's going to go wrong yet and what's going to go right yet. And so that sort of like open discussion between policymakers and technicians, be them, be they at Microsoft or Google or at a startup, like Arthur, we're about 40, 50 people. I think that's going to be very, very important in the US, in the EU, and everywhere else. I think we're also obviously going to see different countries doing different levels of regulation here, right? Like, so Japan, for example, you can train on anything, or the EU is going much more into regulatory world than the US is even right now. So I think we're gonna see a lot of that sort of differentiation occurring as well. The second question, how will evaluation/monitoring of agents differ from doing so for models? Oh my gosh, this is a hard question. So this is just to sort of like dive in deeply there. This is on the monitoring side of an agent, which is something that can nominally act, reason, learn, perceive, and a model, which is something like just a traditional, is this a cat or a dog? Monitoring agents, I'm going to say that this is actually sort of a strictly harder problem than monitoring models. And I do not think there is a good solution that's out there yet to monitoring agents, right? So now you're going to have to monitor, first off, you're going to have to figure out what is good and bad when it comes to acting over time. And you're going to have to monitor this agent as it goes out and interacts with the world and comes back with partial sort of solutions, comes back with partial information and so on. So yeah, my blunt answer there, just in the interest of time, is that I do not think there are good agent monitoring solutions yet. And it's just a very hard problem. Anonymous attendee asks, are most companies you engage with at the forefront of LLM progress strategically exploring innovative options like Weaviate and Pinecone, or are they still in earlier stages of adoption? Maybe I don't get the... Yeah, when it comes to like companies that use specifically large language models, which is what this question calls out, and they're using the RAG paradigm, they do typically use a vector database. So like I mentioned, if you're just starting with some sort of RAG paradigm, I do this personally, just like make a NumPy array or make a Panda, like just, yeah. You don't need a vector database until you hit a particular scale or until you need particular sort of requirements around the way your system is working. But that next step after that, right, when you start hopping into vector database land, yeah, we see a lot of Weaviate just because it's the open source option. We see a lot of the Postgres, vector data store, starting to see some Elasticsearch, and Pinecone just had a big announcement on AWS, I think, last week doing serverless. So like these are all interesting players in the space, and like the minute you need to move away from that single like giant array full of information into a vector database, yeah, we see them all over the place. Cool. And then I guess there's one last question as I hit an hour. Do I expect small application-specific trained models to win versus large foundation models? I see. So this is a classic question. And I've been very, very open about this. There's obviously a ton of value in these enormous foundation models. But I believe, and also it's my hope, that smaller task-specific models will sort of take over. And I think we're starting to see a lot of cool success here. So out of Microsoft, we had Phi 2 that came out, which is tiny and very, very, very good at particular, say, code completion tasks relative to even like the major GPTs. And I think this is going to be the year of people realizing that running enormous models, although they work obviously extremely well, you can do as good for your particular use case. And this comes back to, I believe Mick was talking about evaluation questions. What is good or good enough? I think you can do good enough in most applications with a cater fit smaller model, and you're going to save a lot of money. You're going to save a lot of power. And so, I think this will be an interesting year for that as well. Cool. Well, thanks everyone for hopping by for an hour. And if you have any additional questions, I have my email up here. It's just john@arthur.ai. Do feel free to reach out, and hope to see you soon.